And it looks like we're starting to level off. So today might be a little bit different from some of the things that we've been going over so far in the boot camp. We're going to not so much be doing a lot of techniques for building things. We're going to be looking at techniques for analyzing things, looking at other people's applications, and coming up with some techniques for troubleshooting our applications, which is applicable when we're building things. So let's jump into the pre-recorded video, and that's going to walk us through the topic and basic installation of the tool that we're going to be using.
In part one of this talk, the pre-recorded section, we're going to cover just a bit of an introduction. Learning objectives for this lecture are going to be developing a couple of new skills using the Internet Computer Inspector, IC Inspector. So we're going to be able to, using this extension, understand any IC app that's running in the browser, approach improving performance for any app, troubleshoot our canisters during development and during analysis of other people's canisters, generally improve our understanding of how the browser communicates with the internet computer, and in general become an internet computer wizard. So part one, a bit of an introduction. We're going to go over the basic installation of the extension to get you up and running. Then we're going to cover the basics of the extension, so you know your way around. And then in part two, in our live lecture, we're basically going to dive into a number of different apps and do some analysis. So as a basic introduction to the extension, you're likely familiar with using your browser's developer tools during web development, and they're awesome. But unfortunately, when you're developing on the internet computer, they're not so awesome. They need some help. So if we take a look at an example of an application, perhaps Discover, and we just open up our network tab, I'll filter requests to those being sent to the default boundary node. We can see we're making a bunch of query requests. These read state requests that we're sending are one part of an update message. So when we're sending an update message to the internet computer, we send multiple requests from the browser. We send initially a call where we pass the parameters of our update request, and then we send a series of read state requests to the boundary node attempting to read the response of our update. So if we take a look at one of these, let's have a look at the response. We can see that the encoding doesn't really allow us to read this response at all. That's because requests to boundary nodes are encoded as CBOR, concise binary object notation, and they're also encoded as candid. So we need to decode that in order to read these requests at all. So if we go over into the inspector here, and we wait for some notifications or wait for some messages to come through, we can take a look and see that the response is much more readable. So this is a very powerful tool. I use it all of the time in my day-to-day work. I built it to scratch my own itch, and a lot of the big internet computer teams use this as well. It's also totally free, and it's open source, just in case you were wondering. It was built originally for Chrome, which means that it works in all sort of Chromium derivative browsers, Brave, Microsoft Edge. And Firefox is releasing, I believe it's version 109, later this week as of this recording. That's going to be January 17th. And this version of Firefox will bring with it compatibility for the extension as well. So let's get started by installing. And you can use these bit.ly links here if you want, bit.ly/IC Inspector Chrome or IC Inspector Firefox, and that'll take you rate to the listing in those browser extension stores. Or you can just go to the Chrome Web Store, the Firefox add-ons directory, search for IC Inspector, and we should be the first result. So I'm on Chrome, so we'll do this on Chrome. The process is very similar if you're doing it on Firefox. I already have it in Chrome here, so I'll remove it, and then we can just add it again. And it really is as simple as hitting Add to Chrome, and there it is. I'll install it one more time and make a brief note on the permissions that are being requested. We're being told that the extension can read and change all of our data on all websites, which sounds like the most permissive option possible, and it's kind of spooky. It seems like too much power. Actually, we don't request, or this extension doesn't request any permissions whatsoever from the browser. Firefox actually does a better job of listing what the extension actually requires access to. So as an example, we'll add this extension, and then we can always see which extensions have access to the page that we're currently on just by opening up the extensions tab here. We can see the following extensions have full access to this page, and these extensions are requesting access. And we can see IC Inspector here, no access needed. This will be the case basically on every page that you go to. IC Inspector does not require access to the page. Where it does gain access is when we open up developer tools, and then when we go to the IC Inspector tab. At this point, it has access to network events coming through the page. Up until that point, it does not have any access. So in case you were wondering, developers are a security-minded bunch. So now that we have the extension installed, I have noticed oftentimes the tab in developer tools won't show up right away. And sometimes restarting Chrome is required. So if you don't see the IC Inspector showing up, go ahead and restart Chrome. I've also found there are certain web pages that prevent the tab from showing up, but it hasn't ever happened on a page where I require it. So for example, if I open it up on the Chrome Web Store here, I'm not going to be able to see it, but that's fine because Chrome Web Store isn't talking to the internet computer. So that's the basic installation. You can also install it manually if you'd like to. I won't walk through exactly how to do it, but just quickly, you can go to GitHub and download the latest release. And then in your Chrome extension settings, you can enable developer mode. Then you'll see a button to load an unpacked extension, and you can just drop the release that you downloaded into that. You might want to do a manual installation in the case that there's a new feature being released in IC Inspector, and you don't want to wait a couple of days for the Chrome Web Store to approve those changes. You can just go and install that manually. Or if you wanted to fork it and add some of your own features, you can go through basically these same steps. So now that we have the extension installed, we'll go through its basic functionality. So the most basic functionality, obviously, is just to capture some messages. So we're going to open up DevTools, and then we're going to go to this IC Inspector tab, and then we're going to play around with the red recording button. So let's go back over to Discover here, and let's purge the logs that we've captured so far. And we'll go ahead and just turn this capture off, and we'll notice that no longer are there any messages rolling in. So you'll find that some internet computer applications they're very, very message heavy. You might get spammed with a lot of messages, which can cause you to lose track of the particular message that you're interested in. So what I like to do is to, as soon as I isolate the message that I'm interested in, I can just turn off capture, and that makes things just a little bit more sane in those message heavy applications. So capture does not start until we're actually, we open up the developer tools and go to the IC Inspector tab. So if you're finding that the messages are not showing up here, then what you can do, make sure capture is enabled and just give the page a refresh, and then we're capturing all of the messages from the first page load. So some more details on capturing messages. There is a soft limit of 100 messages. Beyond that, performance is taking a bit of a dip. So you can increment that that limit if you'd like, but your mileage may vary in terms of performance that you get. And we covered stopping capture and clearing capture with the two buttons that are available. So we also have the ability to filter messages. So I'm going to disable capture. We have a number of messages here. And here in the filter search bar, we can type in pretty well anything here. So you can see we're talking to the wrapped ICP canister here. We could type in the name of the canister and that would show up. We're calling this balance of method, filter by that. It's a very general text search. It searches through all the available fields for each message. So of course, this can be very handy when you're trying to capture a particular message. We also have access to a bunch of metadata for the canisters. And we'll take a look at this. So if we pick one of these, let's say this balance of call to your coin. I'm not sure what that is. So we pull a description from the DAB directory. We could say, oh, this is the token for SIGDAO. It's also a novel DeFi self-staking technology with a tax system that encourages holding. Interesting. We can see the controllers of this canister. We can also open up a link to the full Candid interface using Candid UI. And it looks like there's a problem with the Candid UI canister right now. It might just be for this particular canister. Let's try another one and see what we see. So this is an unknown canister of some kind. We'll open it up. Interesting. Definity's Candid UI canister seems to be having issues right now. Hopefully that resolves itself in time for our live coding demo. But this Candid UI can be very handy for reviewing the whole interface of a canister and poking around at it a bit. We can also see the subnet that is running the canister for this particular message. So we can jump out to the dashboard here and check up on the metrics for this subnet. So jumping out to check on the subnet is always a good first step if you're noticing some strange behavior, a dip in performance of the canister, long load times, failed requests, unexpected errors. Jump over to this dashboard, which again is easily accessible through the extension. And what I like to check on is finalization rate. If we see this finalization rate taking a significant dip, significantly and consistently below 1 block per second, then we can have some certainty that the subnet is to blame for our problems. And it could be due to increased load, could be due to a large deployment of canisters, etc. We should be able to identify what's going on here. And that can save us some time in terms of identifying that it's a subnet and not something in our code. We can see the caller. So this is the principal that signed the message. Presumably this is my discover principal. And we can also see the requests that were made by agent.js in order to fulfill this message. So we only have a bunch of query messages here, but if we were dealing with an update message, we would be able to see the original call request as well as all the subsequent read state requests. We would see when those requests were made and an aggregate of the duration of those requests. So we can see for each of the messages the total duration of requests to complete that message, which can be really useful for determining where slowness might be in our communication with our canisters. Now we've covered agent requests. So that's it for the pre-recorded session. We're going to jump into live coding and start to do some analysis on some internet computer apps running on mainnet. In part one of this talk, the pre-recorded section, we're going to cover just a bit of an...
Okay, on to the live section. So I'm going to walk through basically just analyzing a couple of different apps on mainnet. And first, I'm going to figure out how to close VLC. There we go. So if anybody actually has any applications that they would like to take a look at and to analyze, and we can start to figure out how they work, feel free to drop that into Q&A and we can poke around and try to identify something. All right, so there's a bunch of different ways that if we want to go and understand some application that's running on the internet or on the internet computer, different approaches we can take to try to learn how it works. So we could read the documentation, which is obviously a great option because we'll get it explained to us by the people who understand it best. But you know, a lot of the times we don't have good documentation or the documentation's out of date. And that can be more harmful than it is helpful. So we can't always read documentation. We could also get our hands on the source code if it's open source, or if we know the creators and we can get access to the repo, or perhaps we could just talk with the creators and get somebody to introduce the application to us. But that's not always the case, that we have a relationship we can use or that the code is open source. And so what we can always do with something on the web is to just analyze the thing in production and see how it works, monitor it, poke at it, and just see how it behaves. So that's what we're going to be doing today, going straight to the horse's mouth. And there's a lot of benefits to this approach. Like we can isolate just the specific behavior that we're interested in, a particular feature that we're interested in, without having to load the whole application up in our heads and figure out how the whole thing works. We can just say, I wonder how this particular feature works, set up our tooling to monitor it, and then just see what it does. So the first app that we're going to look at is Discover. And let's take a look at a bit of an approach that we can use for, okay, we want to analyze this thing in production. How should we go about this? So what we could sort of call like a mainnet message analysis is this framework with a couple of steps to it. So we're going to pick an application. We've picked Discover. Then we're going to choose one of its features. We're going to say, I wonder how this particular feature works. So on Discover, there's this feature that allows you to tip people for different posts that they've made or comments that they've made. If you think it's really cool, you can tip them with some of the tokens that you hold. On this support like a bunch of different tokens. So we'll take a look at that particular feature. So we're going to capture messages while we're using that feature, and then we're going to just start to build some intuition for how this feature works and reconstruct the messages that we would have to send and the data that we'd have to send in those messages in order to implement that feature within our own front end, say. So this is what the tips feature looks like. At the top of each post, we can choose or we can see how many tips each post has gotten. And then at the bottom of a post, we can provide some of the tokens that we hold as a tip to that post. So let's jump in. I'm going to log in so that I have some tokens to tip with. Just give me a second while I do that. Okay. So we're signing in. I'm going to clear out the message log here. And then I'm going to start recording messages. So here we have the tips that this post has received. And this post has some baby error off, some ghost token. Discovered keeps adding more and more tokens. I can't keep up with them all. So as we just kind of scroll through and see, okay, these ones have received so many tips and that one's got that many tips. We can see that we're making a bunch of, I should probably make this a bit bigger so that everyone can see the messages coming in. We can see that we're sending out a bunch of query messages to this canister here. And we're going to say we're only interested in analyzing things that have tips in the name. So we've got tips of content IDs, and we're sending it out quite a lot. So it seems that, you know, as we're scrolling through the page, Discover's determining, okay, we need to know the tips for this content, and it's just querying them as it needs that tip data. So I am going to analyze, just take a quick look at the response that we're getting back here. Let's take a look at the response. So we've got a big list of, let's have a look. So we have a to field, we have a token from, so this seems to be a tip was sent to this principal from this person. And they sent this token here, and it's related to this content ID. And then we have a transaction, and this transaction looks like a pretty standard token transaction. We can see the amount was 250 some number of zeros, 25 some number of zeros. So as we're scrolling through, we can see it's just querying these tips of content IDs. Okay, cool, good to know. In terms of the payload that we're sending along, we can take a look at this and see, this is just an array syntax that's been forced into an object syntax. So our incrementing keys going upwards here, and we're passing in a bunch of numbers here. This method is called tips of content IDs, so we can probably say these are a bunch of content IDs that we're requesting tips for. So we have access to this tips of content IDs method. We can see the basic interface here is we just have to find a bunch of content that we're interested in, and then we can post to this endpoint, and we'll get back all of the tips there. This canister is not listed in DAB, so we can't see a name for it or read a description about it, but we could open up the candid UI for this canister. And let's maybe set this off to the side here and just reorganize this so we can have this visible to us at the same time. It's getting a little bit cluttered, but so if we haven't used the Candid UI before, it's a nice UI on top of the Candid interface exposed by the canister. And so we can scroll through this and get a sense of all of the methods that are available. So we've got adding an admin here. Presumably I can't call this with my anonymous principal. Getting all of the tips. We've got a few sort of logging things here. Processing transactions. So this appears to be a canister that processes the tips for all of Discover, as well as giving us the ability to query those tips. What else do we have? We have tips of content ID. This is the message, the query that we were just looking at. And it looks like we have some other query methods here. This might be a little bit small. I apologize. I am just running out of screen space. So we can see tips of a particular sender or tips of a particular recipient, but there isn't any messages here that I can see for if I wanted to send a tip. And we want to understand how to send a tip as well. I see processing transactions, process tips, but there's no arguments on that. So there's another mechanism for sending tips that is not exposed on this canister here. So let's have a little bit of a deeper look, and we'll see what happens when we actually send somebody a tip. And hopefully we'll learn something that way. So I'm going to get rid of that to recover a little bit of screen real estate for us. I'll get rid of my filter here, just in case the message that I am interested in gets filtered out by that. Start recording messages again. We'll get rid of everything that we had so far. And let's tip this individual here for his post on 3D printed Bitcoin. It seems I don't own any tokens, so that's going to make this harder. I might have to switch accounts. Oh, apparently I do have tokens. Okay, so we're capturing a whole bunch of messages on page load here, kind of getting swamped. But it's also interesting in its own right. We can see, all these different canisters that we're talking to. So we can get a sense of what Discover is doing more broadly if we want, but we're just going to stay focused on the tips functionality here. All right, so purging the logs, turning message capture back on, and then we are going to, we'll just tip the top post here, and we'll tip it with 100 ghost token. And it looks like I'm very, very low on tokens to tip with. So let's make sure that we capture this message and learn what we need to learn, because after this, I think I'm out of tokens. Okay, so I got a big burst of different messages after sending that tip. A lot of tips of content IDs, checking balances. So I guess after I send a tip, Discover is checking my balances on different tokens to see what I have available to tip with. But we also see this transfer method here. So I'm just going to filter down so we can just look at this transfer method. And this principal here must be the ghost token. I must be transferring my ghost token here. So if I take a quick look at the Candid UI, we would expect to see the interface for a standard token contract here, which is exactly what seems to be the case. We've got approve, we've got balance, allowance, transfer, obviously, mint. So this is our token canister. So I've sent my tokens, and we can take a look at this payload. So we have a nice fully decoded payload here. Sometimes we won't be able to see the names of the keys in our object here, and I'll touch on that a little bit later. But in this case, we have a beautifully decoded response, and we've sent these funds to this address here. So curious how this works, we can take a look perhaps at this address and see what other transactions it's taking, and perhaps we'll learn something this way. Okay, we'll try IC scan instead. So we just want to pull up this account that we've just sent our funds to figure out what other transactions it's processing, to hopefully get a sense of what its responsibilities are. We're having a hard time getting these block explorers to work with us, but that's okay. Okay, so it seems the reason why we're having a hard time analyzing this address is that it doesn't have transactions on it. It must be the case that IC scan hasn't integrated this particular token canister's transaction history. So I'm actually not sure where the limitation is there. It could be that this ghost token is using CAP and IC scan hasn't integrated that. But that's too bad. We're not going to learn anything in that direction. So we'll take a look at this payload that we've sent in a little bit more detail. We can see the from address. This must be my discover address. We can see 100 and a bunch of zeros. So that definitely seems to be the number that I sent. And then we have this big memo here. And this memo appears to do something. Perhaps if I was able to decode that, we could look into this process a little bit further. Unfortunately, we don't have the ability to arbitrarily decode memo fields. Someone can put kind of anything they want into it. So that sort of brings our analysis to a close on Discover. But what we know is we can query the tips on different pieces of content, and we can send tips to content using this transfer function. But we'd have to dig a little bit deeper into where that, or how that memo field is constructed, if we wanted to fully get to the bottom of it. So hopefully we're starting to develop some intuition on like a general process that we can apply for working through understanding an app that's running on the internet computer. So just to review, we've got users can see tips, which is basically they're reading which tips are there, and then we have they can send tips, which would be a write operation. In review, we're analyzing capturing messages. We've looked at the candid interface, and we'll skip through some of this to save some time. And what we're going to do now is we'll jump onto another app. So I'm just going to take a minute and review our chat logs here and see if we've got an app that people are most interested in taking a look at. So we've got Portal. This is a suggestion from Lee. We've got a project from Denny from the Supernova Hackathon. And we've got Hot or Not as a suggestion from Ellie. So another Hot or Not. Does somebody want to give me the Hot or Not URL, please? And for the moment, I'm going to try opening up Denny's link because he gave me a link, so that makes it nice and easy. All right, so we'll see what we're doing here. Open up the inspector, and so far we don't see any messages rolling in. We don't actually capture messages until we have this tab in Developer Tools opened up. So it's always a good idea to get it open and then hit refresh, and we'll see what messages come in. So now we can see that we're sending HTTP requests to this canister, which is the one that we're on right now. But because this HTTP request goes to the boundary node, that's going to be captured as a message. Okay, so let's log in with my internet identity. And I'm just going to do that over here off screen. Thank you for the link, by the way, Frederick. We'll take a look at that one next. Okay, so I don't know how to pronounce this application's name. That's fine. Hot or not might be a better analysis because I can actually, you know, I know a little bit about what that app does, but let's have a go here. I'm not even sure what this product does. So we're going to create a test topic. Maybe Denny, just fire off like a quick intro for what your project does here. So we can see that we're talking to this canister here. This is the backend canister, I presume. And you know, let's say, for example, that while we're working on this project, you know, we're getting a lot of weird errors. Like I mentioned in the pre-recorded section, it's nice that we can jump right out to the subnet that's running this canister from the IC inspector and see if it's running well. We can see, cool, like our subnet's running totally fine. Finalization rates hovering around 1 block per second, so that's healthy. Good to know. And we've got a bunch of query messages going off here. Topic lookup, card lookup. So we've got topics and cards as 2 different entities. We've created our topic here. And we can see that this is the name that we input. We're generating an ID on the front end. And then we're sending along a bunch of metadata that seems to be generated for us by the front end. But let's see if we can create a card. I imagine this is going to be a card creation thing here. Very cool. Test card, and we'll put a checkbox on it. So we should see an update message here for creating our cards, and we do. That's great. It's not giving us a response back. It's just taking the data. So it's inserting a card, and it takes the ID of the topic that we're under, and then updates its list of children card IDs. So we can make a hypothesis here that when we add a second card, we're going to be sending a new request that has our new card in children card IDs here. And this is something where if we were curious about, we wanted to reconstruct a front end so that we could use this backend canister, a question I would have would be, should I send the full list of children cards in this parameter here, or should I just send the one that I want to add to it? So let's find out what the answer to that's going to be. I'm going to filter the messages down so that we're only looking at this method, which we know is called when we're creating a new card. We'll do a second test card. And you can see these are pending. And that's done. We can also see how long these are taking. So this is a bit of review from the pre-recorded section, but we can tell if our user experience is slow, we can come over here and see how much that time is going to different update messages. And perhaps we're chaining a lot of update messages together and things are getting slow. Here, it seems that, you know, we've created 2 card insert messages. So that's a curiosity. We've got the first one having children cards being an empty array, and the second one also being an empty array. It looks like my assumption was incorrect. So a card can have children, and we just call this, and it generates an ID for us on the front end each time we want to create a new card. So this children card ID isn't what we use when we want to create new cards. So you can see just by playing with this, we start to build some intuitions about how this application works. And if we wanted to, we could tell exactly what we need to do to replicate this front end. You can also open a card and add blocks. Cool. All right, well, let's take a look at hot or not, because I'm actually curious how this thing works too. So buckle up, because we are all learning at the same time now. Okay, so how much of this runs on the internet computer? right? That would be a good hypothesis to start with. I don't know. And like they're processing rich content, you know, videos. Holy, look at this. Look at this. The UI got ugly on us. Okay. Must be, is there like a really long message name in here or something like that? Who knows? All right. We're basically just calling get individual post details by ID. So the app is asking for a singular post in each message request. We can see that we're talking to a couple of different canisters here. XWQ, DU7, two different canisters that, three different canisters, a handful of canisters that all seem to have the same interface. So it seems like we have like a batch of canisters that are providing us with our data. Presumably that's a scaling concern. So let's see what we're asking for here. In terms of the payload, we don't seem to have anything in there, which is curious. That's strange to me, right? Because it says we're getting a post by ID, and the payload is empty. So let's take a look at the candid interface for this, try to figure out what it's doing. And we'll just see if we look for get individual post details by ID. Yeah, it should be taking a NAT64. So it seems like there's a glitch that I need to look into here. We can't see the payload that's being asked for there, but we know that it's just going to be a NAT64 of some kind. So we'll just run with the assumption that we're requesting an ID, and then what we get back is this big payload that tells us all about this post. So what do we have here? We have the status is it's been uploaded. It has a ranking score, so this is their algorithm for what we get to see when we show up on Hot or Not. It's got some different hashtags. It's a trending video. It's got 29 likes. Description, total view count. I want to find out where this video comes from. That's what I would like to know. So we've got who created it, created at, username, and then we have a video UID, and then we have a hot or not ranking score. Okay, so it looks like, as you would presume, this video is not being hosted on the IC. It's being hosted somewhere else. So I wonder if we just try to, let's say, let's refresh. We'll take a look at the network requests that we're sending off here. And we'll just say we're looking at our media. No media. All right, I don't see this video in the requests here. It could be that it's cached. All right, somebody in chat, help me out. How do I go to the next video? Arrow keys? Arrow keys. Excellent. Okay, so now let's flip through videos and see what we can see. Maybe we'll learn something about where the video content comes from. Pretty slick app, to be honest. Nice pickup. Okay. So it looks like we have like the back end of which videos exist and all of the user data that seems to be hosted on the IC across like a cluster of canisters that seem to have the similar, if not the same interface for scaling reasons. And then we take the video ID that we get from the IC and we go and just fetch that off of Cloudflare. So it makes a lot of sense. It's oh, that's interesting. Let's take a look at that message there. That makes a lot of sense, right? Like we've got the canisters on the internet computer doing the job of holding all of the data. And then when we need something that's really fast and performant, we're using Cloudflare and its content delivery network to get rich video content to users immediately. It's a smart hybrid model. So that's makes sense. That's interesting. We've learned something. But we've also got this other big message here that came in that I'd love to just take a quick look at. So we've got get top posts aggregated from canisters on this network for home feed. Whew, that's a big one. That's a very big one. Can we see what's being sent there? Probably shouldn't spend too much time on this one because I want to leave some time for Q&A. It's just another post fetcher of some kind. Okay, so before we switch over to some Q&A, I just want to look at one more app, and that's going to be, could be a number of different apps, but we'll say we're going to go with Sonic. So we won't have time to do a full analysis, perhaps, of Sonic. There's a good feature, though, if we wanted to sort of troubleshoot or learn how this app works, would be to look at how it does swapping. So if we wanted to write a bot that does some swapping for us, how would we actually perform those trades on Sonic? That would be a nice thing to know, but we might not have time for a full look at that. But I just wanted to call out a unique quirk when we're dealing with wallets that are based on a browser extension, which Plug is such a wallet, Infinity Swap is such a wallet. So let's go and connect with Plug. I'm going to give it access to my wallet, and we're gonna turn on message capture here, and we're going to try to figure out what happens when we perform a swap. So we've got a few messages rolling in already, but I want to tell exactly what happens when I perform a swap of some kind, so that I know how I could go and write my trading bot. And let's trade some wrapped ICP for some wrap cycles. Please excuse me. Is a good way to fund your project with cycles. If you're willing to do a little bit more work, you can save some money this way. So that might be why you want to write a bot. Not interested in all those messages. I just want to know what happens when I perform a swap. So I reviewed my swap, and I'm going to hit swap, and I can see it's telling me that it wants to approve ICP, deposit, swap, withdraw, and then that's mirrored in my wallet here. It's going to do approve, swap, deposit, and withdraw. So I'm going to look for these messages happening in the message logs here, so that I can, figure out what they're doing and recreate it. So apparently I've approved, I'm depositing, and I see a lot of messages popping up here, but they're all the messages that were already popping up when I was just looking at this page. I don't see a swap, I don't see a deposit in here, and I don't see a withdrawal. So the reason why I can't is because this being a browser extension based wallet, the messages aren't being sent from this page that we're on. They're actually being sent from the Chrome extension. So we're going to jump over to our extensions. And apparently I have no extensions. There we go. And we're going to take a look at Plug. So Plug here in our Chrome extensions allows us to inspect the extension itself, and we can see what the extension is doing. We'll open this up, and we have our IC inspector here, and we'll just set this off to the side like so, and we will try again. And now that we have our messages coming from Plug, we don't even need to look at the messages coming from the page itself, and we're going to try this again. So we'll send 0.01 wrapped ICP, and we'll get some wrapped cycles back. And it's going to, again, ask me if I approve. And yes, I want to see approve deposit, swap, and withdraw. So we can see we've actually already got a couple of messages coming in before we even sent the swap. There we go. Approve, wrapped ICP, deposit on the Sonic swap. And then we'll see swapping. And now we have, if we wanted to go and write our trading bot, we can just capture this code here. So we need to send this payload, right? So we can capture that. And now we know exactly what we need to send along with our approve request. In our response view, we can see what we expect to get back. So I would copy and paste all of this data over into, my work zone if I'm working in VS Code. And now I have a reference for exactly which messages I need to call in what order with what data if I want to perform a swap from my trading bot. Cool. Okay, so we've got, I think, just a couple minutes before the top of the hour. So if Seb or Isaac, if you guys are here to sort of just shepherd the timeline a bit for me, let me know. But if anybody has any questions about what we've gone over, toss them into chat, toss them into the question and answer, and I can go over those.
All right. Well, thank you so much for that, Dorgan. That was awesome. And yeah, so I'm just looking through here, and some of these questions I feel like we may have already gone through. I see one from Mike Brunt. We're not going to have a session dedicated to using the dashboard, unfortunately. And some of these are just suggestions for dApps people want to look into. Anonymous intent, yes, is it possible? Dump to see in plain text encrypted info about the blockchain transactions. I don't think so.
Yeah, if it's encrypted, it's encrypted, and we're not gonna be able to break it. If it's encoded, into candid, then that's exactly what we're solving here. And there's a lot of transactions that happen on the internet computer that they're not encrypted. And this extension does give us like a good jumping off point to look at those transactions. Anything that's sent from the browser we'll be able to see. And then we can jump out to something like IC scan to look at those transactions in more detail if we want to.
Great. Using DFX.
Oh, yeah.
Sorry, go on.
I don't see really. Yeah, I guess this might be a question. Using DFX or another tool, like I'm not sure what to do with that one, but if somebody can parse that into a question for me, I'd be happy to answer it.
All right. Yeah,
thank
if
you,
you want to
Tiago.
raise your hand, Diao Alves, go ahead and raise your hand, and you can kind of like expound on that if you want to. But otherwise, we'll just move on that one. All right, let's see. Tiago just wanted to say that you look, this looks like a great and very useful extension, and thank you for building it. So that's nice. It's Tiago. He's actually over here in Porto as well.
Oh, awesome.
He's been our guide.
Yeah,
He's been our guide. Actually, he lives here. He's been picking out all the restaurants and
I'm sad I missed it.
yeah,
Next
we're
time.
grateful to him. All right, where would the encryption need to take place? That's what HG is asking.
Yeah, so if you wanted to encrypt some information, so that I couldn't just jump into this extension and look at what you're sending, you need to encrypt it, in your front end and then decrypt it on your back end. So an example of that would be when we were looking at Discover, there's a memo that gets sent along, and we couldn't tell exactly what that was. That's not encrypted, that was just encoded. So we'd have to figure out how it's encoded, and then we would be able to back that out. Yeah, you need to encrypt it before it's in transit and then decrypt it after it's in transit. And if you have something more specific in mind, let me know. But broadly speaking, that would be the answer.
All right. Any other questions? You can, if someone wants to raise their hand and ask one live, that's fine too. All right. Well, it seems like this one's ending right exactly on time. All right. Thanks again, Jorgen, for both the presentation and for making this amazing tool available for everybody to use. And I hope everyone has a good rest of the day coding Motoko.
Yeah, thanks everyone. And if you have trouble getting it up and running, or if you have questions about it, feel free to reach out. And yeah, if you have feature requests, check out the open source repo. I think I can. Do they have access to the slides, Isaac? There's links in there for the repo and things like that.
Yeah, actually, well, feel free to send that in a general chat, but also if you send that over to us, we'll try to see if we can find a way to compile it all.
Yeah, you know, it's a Google search away. If you need the repository, just search for IC Inspector. And I love feature requests, bug reports, and all that. So thanks for coming and hanging out today. Have a good
All right.
have a good rest of your day.
Y'all too. Bye.